Well, hello, good people. Welcome back. Math 10. Again, what we're doing is we're using, for this section, you were using polynomials and exponents to solve for problems that use areas and perimeters, using the shapes that we've seen in math class for some time, hopefully. Now, if you take a look, we got questions 3, 4, and 5. So let's get started on those just to give you some examples about how polynomials exponents are going to apply to these shapes and ideas of area and perimeter. All right, so for question number 3, beautiful example. It tells you right away that the perimeter is 12x minus 7. So notice it's not a number. They gave it as an expression this time. And with math people being the way they are, instead of writing the whole word perimeter out, I'm just going to write the letter P there. Usually it's a big P for perimeter. The perimeter is equal sign 12x minus 7. That translates the first sentence. That's it. The question is to find the missing side. What I'm going to recommend, it's always a good idea to write the question in some way at the start. Because you're going to do a bunch of work, you're going to get an answer. You've got to check to make sure you've answered the actual question. Not just get a number and then think that you're finished. That's a mistake that happens often. Okay, so I don't want to do that. I don't want you doing that. Now, I didn't mention it, but it was a formula on the other slide. I felt it was pretty straightforward enough that the perimeter for any shape is, just like the ant did, is adding up the length of the sides that it would walk. So, if we have our buddy here, all right, he would start there, and if he goes up this way, the picture says he's gone x minus 8. From here all the way up to there. See, not an actual number, but just some expression that we can work with. Down here, top secret. They don't say. So in fact, this is the side, the very side that we're looking for. But Buddy goes that far, we got to figure out how far that is. And then we're told that once he's gone up there, down there, he's going to walk back to the start. Oh, missed it. Walk back to the start there. And we are told that this length, this part of the journey, is 8x plus 4. So we got to get this one side worked out. Well, let's do it. Here's what I'm thinking. First thing to recognize is we have the perimeter plus some information about the sides. So I would say, okay, we have the perimeter, and I remember that the perimeter is side 1 plus side 2 plus side 3. See, got lazy right away. Didn't even bother writing side all the time. Just S1 plus S2 plus S3. Okay, well, it's a good idea to always start with a formula to help organize your thoughts. But then what we got to do is substitute the info in that we know. So we are given the perimeter is 12x minus 7. We are given that one of the sides is our first side. It could be the first side that we walked. X minus 8. We then have this side, so we can call our mystery side. We call that S2. And then we go from here back to there. That's our third side. That's 8x plus 4. So remember this thing here, that represents our side 2 that we're looking for there. X minus 8 is that first one. 8x plus 4 is that one there. Okay, so the goal then is we got to figure out what this is. That means, well, we got to start using some of our rules from polynomials in order to help make this happen. So what the first thing we can do is notice on the right hand side of the equal sign we have terms that are the same. That is, same idea, like terms. We have an x here and 8x is over there. So as we know, because they're both x's, we can combine them together. So 1x here plus the 8x over there gives 9x, like that. For the numbers, integers, right? We're down by 8, so negative 8, subtract 8. And then we go up by 4, so we end up just being down by 4, like that. And what's missing? The side that we're looking for, right? Our side 2. I just wrote it out in words just to highlight we're looking for this side here. Okay, should keep S2 all the way down, but that's okay. What do we have on this side? 12x minus 7. So in order to figure out what side 2 is, we got to get this thing by itself. That means we got to move this over to the other side and that over to the other side. Now if you recall with numbers, when everything's moved to the other side, they just change signs. But what I'll do is in a little bit of space down here, I'll move the 9x over. And here's how it happens. Here's how it happens. Because you have a plus 9x, you subtract it from that side. Now, you also subtract it from this side. That's how equations work. To keep them equal, what you do to one side, you always do to the other. Now notice, because I've chosen the same number of 9, and because this is positive, this is negative, you actually have 9 minus 9 there. 9x minus 9x. Okay, it's like 9 bananas. Take away 9 bananas. How many bananas are left? None. They're gone. Okay, so it's gone from this side. And now on the left side, and I'll go up here, we have 12x minus 9x minus 7 is equal to minus 4. I'm going to go back to side 2 just because of the space that's there. Okay, so with collecting like terms, we can go 12x minus 9x, that's 3x minus 7 now is equal to negative 4 plus S2, the missing side. Well, watch this. We got to get negative 4 out of there. So what we do is we choose the same number and the opposite sign. So we add 4 to this side. What now is 4 minus 4? What now is 4 subtract 4? 0. It's gone. That's the trick. But you have to do it on this side as well. So this side will be gone. Subtracts away to 0. And in this side we got to do some work. We got, I can write it out here. It's getting short enough, I think. This left side turns into 3x minus 7 plus 4 is equal to our missing side. Using a little bit of algebra or arithmetic that we know, negative 7 plus 4, this will give minus 3. So on the left side, what do we get? We get 3x minus 3 equal to our missing side there. So the thing to take a look is, can any further work be done? No, x is different than just a lone number, so they don't combine together. So in fact, this expression here, this is the expression for the missing side of our triangle. All right, so what have we done? Let's take a look at it, whole thing here. Quick overview. We have our picture in the beginning. We said that this side here is equal to 8x plus 4, just like in the picture. This is x minus 8. The distance all the way around, first of all, is 12x minus 7. And the distance all the way around is also this side plus this side plus this side. So that starts us here, where the perimeter is just the individual sides added together. Okay, we said the total is 12x minus 7. The one side's x minus 8. The other one is, 8x plus 4. And now the rules come in, so you simplify this side. Simplify being another word for collecting like terms. So we get our 9x, and then we get minus 4. Now we got to do the algebra to get things from one side to the other, so that we have the side 2 on its own by itself. And that's what this part is. Okay, this is what actually happens. So the 9 goes over, it becomes negative. Work it out, or write it out, and then work it out. We get 3x there. And the 4 goes over, it becomes positive. What you work it out, leaving a good-looking final answer of 3x minus 3 for that missing side. Now, I guess the only thing to mention, it's super important, is that if you take a look, this side is length 1x minus a little bit. This is 8x, 8 times that, supposedly, kind of. These plus 4 minus 8 kind of messes that up, but this is kind of 8 times that. And then we got this side here. The longest side in the picture is only a 3. Okay, so listen. Super important. Pictures are usually not to scale. Meaning the lengths, you can't always trust them. What you do trust and we do rely on is the algebra that we have here. Okay, so if you're working through all this, please be happy that that we get that far and get this. But because in fact this is the correct solution for this perimeter, for that side length, and also that side length as well. All right. Let's get on to the next question. Lucky number 4. So for this one, they don't give a picture at all. And that's something you really want to do. So if you don't have a picture there, you have to draw one in. I'm probably going to ask for it anyways, but honestly, it's a habit that you should get into. So square is what they're saying. So square is what they give. It says find the length of each side. Okay, so we have length here that I'm going to write with L. Normally we use X all the time, right? Solving for X and such, but I guess the thing to recognize is X is inside of this expression here, so I don't want to do that. I'm going to use L instead. Okay, so 4 L's because they're with a square. All the lengths are the same. In the question, we're given the fact that the perimeter is 44 x to the power 3 plus 36 times y. Okay, now remember, our answers are not going to be numbers. Our answers are going to be expressions that have x's and y's in them. Basically, it'll look like the question isn't finished. But that's just where we are now. That's the type of math we're getting into. So, because this thing is a square, I happen to remember, well, actually not because it's any perimeter, just add up all the sides, right? Well, for us, that's L plus L plus L plus L. Right, but really, what happened is as it was presented to you, is that the perimeter for a square is 4 times the length of a side. I think the formula used S for side, which makes sense, but hopefully you're okay with L as well. So here we go. What we can do, we have this fact for the perimeter given to us. So we'll put this in here. The perimeter is the same thing as 44x cubed, 36y equals 4L. Okay, I might notice, by the way, beautifully written, if I may say so myself. All lining up vertically, right? The equal sign, fantastic. Okay, maybe not so fantastic, but almost fantastic, right? Left side equals right side. This looks great. So, to get the length, we got to get the 4 out of the way. Okay, that is the length here is multiplied by 4. So what we do is we divide now everything by 4. Because watch, when you divide by 4, 4 divided by 4 is 1. 4 divided by 4 is 1. I crossed them out. And 1 times L is just L. See, so choosing the opposite operation, it was 4 times L. Choosing the opposite, and the same number, we can get L by itself. Well, what we do to one side, we do to each thing on the other. Okay? If there were 10 fractions, each of them gets divided by 4. Okay, but only 2 in this case. And now, hopefully, you can take a look at this without all there's a lot going on here. Take a look at this on its own. This is like simplifying an exponential fraction, right? Numbers on the top, numbers on the bottom, x's and such. Right? Cancel, cancel. That's what's going on. The application of our exponent work. So, simplifying this, what's 44 divided by 4? Good. 11. X cubed divided by any x's down there? No. Stays as x cubed. Same style over here. 36 divided by 4, what do we get? 9. Y divided by anything? No. So it's actually an easy exponent type question. Right? So it just stays as y. Oh, look at this. Maybe not so neat. Okay, it equals L. That way has the L that I put there to cross out just to make it all line up now. Okay, so we have our, we do our dividing. 44 divided by 4 gives 11. X cubed stays. 36 divided by 4 gives 9. Y stays. And there we go. What we have here is the length being equal to this expression there. And that is finished. Let's take the last one, number 5. But what we'll do is those 2 questions in the next video. So please take a moment, stretch, and come on right back.